Today we have the hyperbola, and this is a pretty simple hyperbola, and we're going to go through all the basics of it. We're going to draw both branches. Yes, that's what they're called, branches of the hyperbola. We're looking for an axis of symmetry. We're going to have two of them here. I'm going to give them two different names. One's going to be called the transverse axis. The other one is the conjugate axis. We only have two vertices, but we also have two foci. Now, the coolest part of the hyperbola is drawing in the asymptotes, and that is my preference in drawing a hyperbola, is not to draw the box, which if you look at other videos, you may see other mathematicians drawing a box in order to draw the hyperbola, but I prefer to just find the equations of the asymptotes and graph them first. So let's get started with x minus 3 squared over 25 minus y minus 2 squared over 16. And let's go ahead and highlight that first big difference from the ellipse. The ellipse is a sum. The hyperbola is a difference. Now, also the first thing we need to look at, or second thing we need to look at here with the hyperbola, is that a squared is always going to be within the positive portion of the equation. So 25 is a squared and 16 is b squared. A squared does not have to be larger than b squared in this particular conic section. That's only true in the ellipse. So just remember, a squared is usually first, and it's the part that is positive. So still, however, we are set equal to positive 1. So let's start filling in what we know must be true based on this hyperbola, and then we'll end by graphing it. So the center point is at 3, 2, a squared is 25. So if a squared is 25, then a is 5. B squared is 16. And if b squared is 16, then b is 4. Now in the ellipse, c squared equals a squared minus b squared. But in the hyperbola, we have what we're more accustomed to seeing, c squared equals a squared plus b squared. I hit that for you on the very bottom of the Google site that I prepared for you. So a squared plus b squared, 25 plus 16 is 41. Therefore, we have a c value of the square root of 41, which is approximately, we'll say 6 and some change, 6.5. Okay, so let's go ahead and start graphing what we know so far, and I am going to squeeze it on this graph paper, and then I'll zoom in on the graph just so you can see all of it. So first of all, we are over 3 up 2. So there's our center point. And then, how do I know what type of major axis? And we normally don't call it a major axis in the hyperbola. We call it a transverse axis. Once again, we look back at what part is positive. In this case, the x squared is positive. The y squared is going to be negative because it follows that minus sign. So since the x squared is positive, we know that we have a horizontal transverse axis. The horizontal transverse axis. And if we have a horizontal transverse axis, that is where the vertices are going to live, and it's also where the foci are going to live. So we have a horizontal transverse axis cutting through here. I'll do it in orange. Cutting here. So horizontal transverse axis in orange coming through right there. Okay. Zoom and be sure everything is focused for you guys. All right, so horizontal transverse axis cutting through the center point. Now, let's use that C value, or excuse me, the A value first, because the A value is going to tell us, well, how far from the center point are our vertices? So we're going to go 5 to the left and 5 to the right. 1, 2, 3, 4, 5. There's a vertex. And then 1, 2, 3, 4, 5, there's a vertex. So vertex number 1 and vertex number 2. Our foci are going to be root 41 units to the left and to the right from our center point. So if this is 5, this is 6, and root 41 is about right there. So 5, 6, 6 and some change. So we've got focus 1, vertex 1, vertex 2, focus number 2. Now let's use that B value. Actually, we're going to use the A value and the B value in order to find the asymptotes. So here's something to definitely write down if you do not have it yet. If we have a horizontal transverse axis, our equation for our asymptotes is going to be y minus k equals plus or minus b over a times x minus h. Now, I'm sincerely hoping that everyone listening to this video looks at that and goes, my goodness, I just had a flashback to Algebra 1, because all this is the point slope form of a line, where b over a is going to give us a ratio which represents the slope, and yes, it will be in the positive and negative directions. And then of course h and k is the line, is the point through which the line passes. So let's plug in our givens. Y minus 2 equals plus or minus 4 over 5 times x minus 3. So this is the point slope form of our asymptotes, and yes, I would like you to simplify it a bit. So y minus 2 equals plus or minus 4/5 x, and then 4/5 times 3 is going to be plus or minus 12/5, and then y equals plus or minus 4/5 x, and then plus or minus 12/5 plus 2. Remember, it makes a difference because really you should do it twice. I'm really kind of running out of room here. It makes a difference because we're multiplying through by positive 4/5 as well as negative 4/5, which is why we have plus or minus here and plus or minus there. So we have two asymptotes. And the asymptotes are going to give our branches direction. Now, the easiest way to graph these asymptotes is not to worry about the y-intercept of the asymptotes, but just to use the slope. Use the slope of positive and negative 4/5, knowing that our asymptotes are going to go through our center point. So let me zoom in on the graph here, and let's graph. Whoop, got a pesky shadow. There we go. Let's graph these asymptotes. So slope 4/5 plus or minus 4/5. Remember, slope is rise over run. So we're going to be rising 1, 2, 3, 4, running 5. 1, 2, 3, 4, 5. Down 1, 2, 3, 4, back 5. 1, 2, 3, 4, 5. Do the same thing in the other direction. Up 4, 1, 2, 3, 4, and then back 5. And really, in using the slope here, you're creating the box that that most other teachers or mathematicians might talk about. And from here, I am going to use my handy dandy folded piece of paper out of the trash bin and draw in some asymptotes. Remember, ladies and gentlemen, these are asymptotes. They are auxiliary. They should not be solid. That's why I'm drawing them with a highlighter, and I am also drawing them dashed. They are not solid lines. They are auxiliary. Please draw them dashed. And yes, those two asymptotes are going to intersect at point HK, which is the center point of the hyperbola. Okay, so once we've got our asymptotes drawn in, the branches are quite simple, because if you understand what asymptotes are, they're creating graphical limits for the two branches. So basically, don't start at the focus, start at the vertex. Remember, the focus is in that interior in the concave part of the branch. And basically, our branches are just going to hug those two asymptotes. So that's what your hyperbola looks like. And we're going to get more deeply into the hyperbola within our practice problems, but that's pretty much the gist of it. You've got to be able to determine the center point. You've got to be able to determine where the foci are. Let's go one step further here with the foci before we leave this particular problem. Because if the foci live on the horizontal transverse axis, if we want to find the locations of the foci, think about it. The K value of all of these points is constant. 2, 2, 2, 2, 2. It's the H values that are changing as we go across this horizontal transverse axis. So vertex number 1 is going to be H plus A, K. So that's in general terms there. So vertex number 1 is going to be 3 plus 5, so that's 8, 2. And then vertex number 2 is going to be 3 minus 5, so that's negative 2, 2. Focus number 1, and I think I've actually got them labeled backwards, so let me fix that. Focus number 1, which is over here, is going to be 3 minus root 41, and you're just going to leave that in simplest radical form. And then focus number 2, which is over here, is going to be 3 plus root 41 in simplest radical form. So now we've got everything we need to know. We know where the center point is, we know where the vertices are, we know where the foci are, and we know where the asymptotes are using this particular formula. So B over A is for a horizontal transverse axis, and it's going to be A over B for a vertical transverse axis. I'm sure we will see that in the practice problems.